Okay, so yesterday you guys learned about the properties of parallelograms. Today you guys are going to be learning about the properties of rectangles, rhombuses, and squares. Okay, so a rectangle, you guys probably have learned about rectangles a lot before. You learned about this in elementary school and in middle school, but a rectangle is specifically, the math definition is it is a parallelogram that contains 4 right angles. So all 4 of the angles must be right angles, okay? Now, yesterday we learned that in a parallelogram, the diagonals were being bisected, but that they weren't congruent to each other, okay? In a rectangle, the diagonals are actually congruent to each other, okay? So this is a special situation in which the diagonals are going to be congruent to each other. Okay, so for example, in this picture here, okay, segment WY, this diagonal is going to be congruent to segment XZ. They're going to be the same size. Okay, the diagonals are going to be congruent. So because a rectangle is a parallelogram, it still has all the same properties that a parallelogram had. Okay. The opposite angles are congruent. The consecutive angles add up to 180. Okay. The diagonals bisect each other, so this part is congruent to this part, and this part's congruent to this part. Okay. Opposite sides are going to be congruent. All right. All of those things that we learned about the parallelogram are still true for the rectangle. The only main difference is each of the angles is a right angle. Okay, all the corners are right angles, and the whole diagonals are congruent to each other. Okay? All right, now, a rhombus. That's the second one we're going to learn about today. A rhombus is basically a parallelogram that has 4 congruent sides. Okay? So in a rhombus, all the sides are going to be congruent. Okay, now a rhombus is still a parallelogram, so it still has all of those properties of a parallelogram. The only difference is all of the sides are the same size. Okay, so we still have that diagonals are going to be bisecting each other, so these 2 parts are going to be congruent. Okay, these parts here are going to be congruent. Okay, and one of the other special properties of a rhombus is that its diagonals are what we call perpendicular, which means they create a 90-degree angle. So that's why you see this 90-degree angle symbol right here, because in this rhombus, the diagonals do create a special 90-degree angle. Okay, the last figure we're going to learn some properties of today is a square. Okay, now a square is basically, it's a parallelogram. Okay, it's also a rhombus. Okay, and it's a rhombus with 4 congruent sides, and it also has 4 right angles. Okay, so a square, it's a parallelogram, it's a rectangle, it's a rhombus, and the most specific name for this situation is square. Okay, it's where all the sides are congruent and all the angles are right angles. Because it's a parallelogram, it's a rectangle, and it's a rhombus, it has properties from all of those shapes. So the diagonals do bisect each other. Okay, both of the diagonals are congruent to each other because it is a rectangle, so it gets that property from rectangle. Okay, the diagonals make a 90-degree angle. Okay, and then opposite sides are congruent and parallel. Opposite angles are congruent. Consecutive angles add up to be 180 degrees. Okay, and the reason why it contains all those properties is because a square is therefore, it's also a rhombus and a rectangle, and let's try to fill in here. It's also a parallelogram. All right. So next what we're going to do is we're going to go through some examples using the properties, okay, that we've just learned up here. All right. Now, in each example, it's going to tell us what kind of shape we're working with. So in the first example, it tells us that EFGH, this shape here, this quadrilateral, is going to be a rectangle. Okay. So if it's a rectangle, that means that all of these angles are 90 degrees, right? All the opposite sides are congruent. Okay, and then in rectangles, the diagonals are the same size and they're also bisecting each other. So I can mark all the parts of all of the diagonals congruent to each other. Okay. All right, so here's what it's asking us for. It says segment EG is congruent to, well, EG is the diagonal. So what would it be congruent to? It would be congruent to the other diagonal, which would be FH, right? I think they forgot the segment notation on top, so make sure you guys put that there. This is the typo, it should have segment notation there. All right, let's look at the next part. So the next part is the measure of angle EHG. I'm going to highlight where that is. EHG. There's the EHG, so that's this angle right here. Okay, equals what? Well, its measurement, because it's a rectangle, it's going to be 90 degrees. All right, and then the last one, segment EH, the length is equal to 6 inches. So I'm going to find EH, which is over here. I'll highlight it for you guys, this segment. Okay, and I'm going to go ahead and fill in that it is 6 inches. And now it wants to know what FG is. Well, let's look where FG is. FG is the opposite side. So this opposite side is going to be exactly the same, so it's also going to be 6 inches. All right, let's take a look at the next part. All right, so on number 2, it's telling you that we're working with this figure over here, which is a rhombus. Okay, so all of the properties of rhombus apply. So it says complete each statement. ML equals 32. Well, ML's over here, so this part's 32. It wants to know the length of LK. Well, in a rhombus, you learned that it's a parallelogram with 4 congruent sides. So if all the sides are the same size, how long is this side? The same as this side, 32. All right, next it wants us to find the measure of angle MNL. Let's look where that is, MNL. That would be this angle right here, MNL. That's right here, that one. Okay, now I know this may be a little bit difficult for you guys to see here, okay, but this angle MNL, this is an angle that's created by the 2 diagonals, right? And so we know that in a rhombus, one of the properties that you guys wrote down up above was you wrote down that a rhombus has perpendicular diagonals. So perpendicular means having a 90-degree angle. So this angle N here is formed by both of the diagonals, therefore it must be 90 degrees. All right, and then last, it says segment JK is congruent to blank, blank, and blank. I think there's another typo here. This is supposed to have a segment line above it. Okay, but if we're looking for what JK is going to be congruent to, segment JK, it's congruent to all the other sides because JK is a side. So it's also congruent to segment KL, which is this side here. It's congruent to segment ML, and it's also congruent to segment JM. Okay, so next let's look at example 3. it says QRST is a square. That's QRST. That's this shape right here. Complete each statement. Okay, it's giving us some information. It says if QT is this side, was 17, TS, well, TS is over here, TS, so that side is 3x plus 5. And then it says RS, which is this side here, is 6y minus 7. It wants me to solve for x and y. Okay, so in order to solve for x and y, what I'm going to do is I'm going to go ahead and set some things equal to each other. I know since this is a square, all four sides are equal, so to solve for x, I could just set these two equal to each other. It would not be helpful to set these two equal to each other because then you'd have two different variables in your equation. So I would set this one and this one equal to solve for x. So I'm going to go ahead and get 3x plus 5 equals 17. Subtract. 3x equals 12. And now divide. And so we get x equals 4. Okay, now we found x, we still need to find y, so let's go ahead and set up this one, which has the y in it, this side, equal to a congruent side, so I could set it equal to this one. So I would get 6y minus 7 equals 17. Now I would go ahead and solve, so I would add 7 to both sides. I get 6y equals 24. And last I would divide by 6, so I get y equals 4. Okay? All right, if you've had enough time to write those down, go ahead and flip over to the back of the paper. All right, so let's do some labeling up here on our diagram, okay? The largest shape we have here is a parallelogram. Okay? The main thing that has to happen for it to be a parallelogram is the opposite sides must be parallel. That is the criteria. Now, if the shape is a parallelogram, it's also one of these other figures that's in here, okay? So, this shape right here, this one is the rectangle, okay? And the properties of a rectangle are going to be 4 right angles. Okay? So, in order to be a rectangle specifically, it is a parallelogram that has 4 right angles. Okay? Now, we could also have that it might not be a rectangle, but it might be a rhombus. Okay? Because a rhombus doesn't necessarily have 4 right angles, but what a rhombus does have is it does have 4 sides congruent. Okay, and then last we have our most specific shape, which is a square. So a square is part of being a rectangle. It's part of being a rhombus. It's also considered a parallelogram. Okay, and the reason why it's part of all of them is because it has the properties of all of them. It has 4 right angles. It has 4 congruent sides, and it has the opposite sides, which are parallel. Okay, let's go ahead and look at the last part, which is our conditions, okay? So in our conditions, our first condition says if 2 consecutive sides of a parallelogram are congruent, then the parallelogram is a blank, okay? Okay, well, think about it. If you have a parallelogram, I'll draw it here for you. You have a parallelogram, and the consecutive sides, which means in a row, so like this side and this side, are congruent. Okay, what does that mean about the parallelogram? Well, if these two sides are congruent, you know, in a parallelogram, opposite sides are congruent, so these two have to be congruent, and then these two would have to be congruent, so you have all four sides congruent. So if you have consecutive sides of a parallelogram congruent, that means the parallelogram is actually, can be named a more specific shape, a rhombus. All right, next, if the diagonals of a parallelogram are perpendicular, it is a blank. Okay, well, what happens if the diagonals are perpendicular? If you flip back to the front side of this page, you'll see that we drew a picture of that, okay? And so that's also going to be called a rhombus if your parallelogram has perpendicular bisectors. It's a rhombus then, also. Okay, next, if one diagonal of the parallelogram bisects a pair of opposite angles, it is a blank. Okay. That would be that it is also a rhombus. All right, and then last here, if a parallelogram can be proven to be a rectangle and a rhombus, then it is a blank. Well, if it's a rectangle and it's a rhombus, then where those overlap, it is actually a square. All right, so last, we're going to go through and use some of these properties to help us solve some problems about these shapes. Okay, so it says, state whether the figure is a rectangle, rhombus, or square. Explain your reasoning. Okay, so let's take a look at the first example. Okay, example 1. It says PQ is congruent to QR. So PQ is here, it's congruent to QR. Okay. Let's see what we can elaborate on, okay? If these two are congruent, okay, then that's going to mean what? Well, it's going to mean these are congruent, okay? And so therefore, what kind of shape is this where all four sides are congruent? Not a square, even though maybe it looks like a square. We don't know necessarily that these are right angles, so we're going to say it's a rhombus. Okay, let's look at the next shape. Okay, and remember, in these, we're assuming all these are parallelograms. Okay, so in this shape, if you had the measure of angle D was 90 degrees, which is right here. If this one's 90, what's this one? 90, if this is a parallelogram, and then this is 90, and then this is 90. Okay, so what kind of shape is this where all four angles are 90 degrees? It's called a rectangle. All right, and then last, okay, it says that in this shape here, QS is perpendicular to TR. I'm going to mark that, QS right here, and TR are perpendicular. That means they're creating a right angle. So I'm marking it. It also tells us that TQ is congruent to QR, so that these ones are congruent. Okay, so if those are congruent, then these are congruent right here. Okay. Now, I have four congruent sides, and I have the diagonals are perpendicular to each other. Okay, I know it kind of looks like a square, but it didn't tell us here exactly what those angles were, so I can't actually assume that it's a square. So this one, it's also going to be a rhombus. Okay, so your homework tonight is to complete the worksheet on properties of rhombus and rectangle and square. Okay, you should have plenty of time to finish that.